Right, anyway, we need to move ahead now. Now, I need Mike for this experiment. Right. I've often told that the best things come in small packages. Mr. Cameraman, we're coming down here.
Mr. Cameraman.
Here, right. Can you all see? Can you see this one? Can you see that?
Yes.
Tweezers. And can you see, I've got a gold block here. Can you see that? Well, it's not gold, but it looks gold. Okay. Now, we've also got some discs here of yttrium, barium, copper oxide. And Mike, hello Mike, how are you?
Very good.
You enjoying Russia? We love Russia. We think Russia's a great place. No, we love Russia. Fantastic place, isn't it? Beautiful city, great science. We're cooling this down to minus 196. And what we're going to do is we're going to show you superconductivity. This is the Meissner effect with superconductivity. And right after that, we won't forget to defrost for someone. Right, okay. We're nearly there. Sam, can we get really close in on this, please? Really tight. Is he getting tight, Mike? Right, and can you see anything? Right, okay. I have here the gold block, and I'm going to hold it above the yttrium, barium, copper oxide. And if it works properly, you'll see something that I think is absolutely amazing. 3, 2, 1. No, that's rubbish. Go on then, cool it down. Okay, can you see it nice and cold? I'll tell you what is getting cold, it's my knees. No, my knees are getting nice and cold. You can see some super cooled knees. 3, 2, 1. Can you see that? Can you see it's hovering in air? Try and get it nice and tight with the camera there. It's actually hovering in the middle of the air, and if we just push it, it should... Go on, Mike. Mike's doing it. Mike knows all about this. Come on, Mike, you can do it. Cool it down. Mike's so cool, he makes water freeze just by looking at it. It's a bit limp, isn't it? It's a bit lame. Right, let's just barrel on with the next thing. Okay, give it up for Mike and his superconductivity, please. Now then, Dave. When we came here, they said, we want to see danger. And I can think of no more dangerous thing than what we're about to do next. We are. Because as soon as Mike makes it over to the sound desk, I'll tell you what we're going to do. Because we're going to use this piece of apparatus here that you're all wondering what it's for. Run, Mike, run. Because we need to have the duh-duh-duh. Because we're going to use 2 terribly dangerous elements. The first of which, 100 milligrams, can kill a man. Yes, I'm talking about the evil element. I'm talking about red phosphorus! No, it's not. Actually, red phosphorus is quite safe. But we're also going to make for you, in front of your very eyes, we're going to turn the oxygen in the very air we breathe down to minus 180. We're going to make for you a terribly dangerous little blue angel they call liquid oxygen! Now, we need someone ready for this one. We need Mike. Give it up for fireworks, Mike. He's wearing a Union flag shirt. Look. Hey, hello, old boy. How's it going? Jolly good. What? Got a cup of tea? Oh, we're English. Sorry, we're English. I forgot we're English. Right, Mike. What are we going to do?
Right. What we're going to do is we're going to pass oxygen gas through a copper coil, and we're going to make some liquid oxygen. So we put the copper coil into this dewar. We're going to need another little dewar, which is right here, and this is going to hold the liquid oxygen as we create it. So Dave, start passing the oxygen through.
Now, I told you before that liquid nitrogen is at a temperature of minus... What's the temperature of liquid nitrogen, please? Minus 100... Minus 196. Oxygen boils at a temperature of minus 180. So if you blow oxygen through liquid nitrogen, it will turn from a gas into a liquid. And Mike's doing exactly that now. Isn't that great, Mike? Right, now, camera, can we get nice and tight on that? Dave, you're going to blow us all up? You can't take Dave anywhere. Now, I hope you can see that there's a liquid developing here. Can you see that? Can you see that?
Yeah.
It's not difficult to see, is it? It's right there. Now, what colour is it? It's blue. Oxygen is one of the very few elements that has colour. It's light blue. Other elements that have colour include chlorine and bromine, but oxygen's there. And that was in the Space Shuttle Columbia. All the Space Shuttle, the Challenger and the Columbia, were full of liquid oxygen, because oxygen is the ultimate oxidant. Okay? Ultimate oxidant, and it's blue, right there. And it's amazing. If I got that on my lab coat, and it caught fire, do you need another jewel to catch the... If I got this on my lab coat and it caught fire, don't even bother to go and get a fire extinguisher, because you can't put the fire out. You can't put liquid oxygen fires out. You can just watch with some popcorn. No, really. English humour. Right, now the reason we're using this is that we are going to make a pure oxygen environment in this piece of equipment here. Dave, hold this.
Okay, so Professor Sosabowski will now pour liquid oxygen into the great round bottom flask. Well, it is great. Well, the large 50-litre round bottom flask.
Explain what's happening when I do this.
And it's going to swirl it around, so we're going to make the so the liquid oxygen will basically become oxygen. Gas. Yeah. Liquid to gases. Yeah.
Oh, it's shaking away. Right, and I need to tell the folks what's going to happen. We're going to put phosphorus in there. We're going to burn phosphorus.
Really?
We are.
Okay.
First man ever phosphorus. Right, gloves.
Gloves.
Yeah. Okay. Right, okay. So squeeze it. Pour. Pour it in, Mike. Right, Mike's pouring in the phosphorus, the red phosphorus. Right, fire it up for me. Here it goes. Oh, look at that. Beautiful, beautiful glowing phosphorus. That's where we get the expression phosphorescence from. And the white smoke is phosphoric acid. It's phosphorus pentoxide, and that's what makes Coca-Cola smell, taste tart. And can you see the nucleation sites are beginning to form here, and it looks a bit like a jellyfish. Does it look like a jellyfish? It looks just like a jellyfish. You think it looks like a jellyfish? It looks like a jellyfish, all right? Yes, right. If I say it looks like a jellyfish, it looks like a jellyfish. Right. Isn't that beautiful? It's a really good one. Don't worry about that, mate. Just a bit of phosphoric acid. Wow. Isn't that great? Oh, it's fantastic. Right. We're coming to the end of our set of experiments, and I think we need to talk about our last animal-related experiment, don't we, Mike? Unless I've forgotten anything. What sheet? The sheet's got covered in water. No, seriously. We need to talk about dogs. Dogs. Because we've saved our last experiment. We've saved it because it's the smelliest and it's the noisiest. And what we're going to do is we're going to show you an experiment. Are you going to sit there? Are you really going to sit there? You're going to stand there. Next to all the explodings.
Not that.
A few more. More. Okay, we're going to basically, we've got gas here. Dave. In here, we've got a gas called, it's the gas that dare not speak its name. It's the gas that dare not speak its name in Russia. We've got, don't tell anyone, we've got, shh, children. Here we've got our secret stash of nitrous oxide. That's my bit on that plate. Right, okay. And what Dave's going to do is Dave is going to hand to me some carbon disulfide. Now, carbon disulfide, like lots of sulfur compounds, smells disgusting, all right? So the disgusting smell that you're about to experience, it's not Dave, all right? It's the carbon disulfide. Now, here's what you're looking for. Nitrous oxide reacts with carbon disulfide, and a blue flame will travel down the tube. And as it travels down the tube, it compresses all the gas ahead of it. And at some point, the compressed gas explodes all by itself. And that's called a diesel explosion. And that's how diesel engines work, isn't it, Dave?
It certainly is.
Right, okay. Ready? Are you ready?
Blowtorch.
Blowtorch, right. Like this. Now, so you saw a blue flame travel and then the rest of the gas exploded all by itself. What's left here is a yellow coating of sulfur from the carbon disulfide. Now, I wanted to finish off with something really big and really good, and I can see that you weren't that impressed. So, well, me and Dave, we bought a bigger one. It's a little bit bigger, so I hope that satisfies and that you can go away with happy memories of how the big barking dog came along. How about that one? Yes, give it up for Dave, come on. Zakroyte uszy. Is that right? Zakroyte uszy. Zakroyte uszy. Zakroyte uszy. Stoi, stoi. Right.
Come on, Twin. I didn't put that white tape on. No, right. Okay. Okay. Now you're going to mix it up. Hal's mixing it up, and he's going to mix all the carbon disulfide gets mixed up in the tube. So yeah, I know. Well, I don't like to see the frightening in your eyes.
Right. Dave,
yeah. Okay.
Right. Give me the microphone before you buzz off. Now, the reason we use these safety screens is because this is an explosion. And the explosion happens at the bottom of the tube. So it tries to get back up the tube. Now, it's only ever exploded on me once, but there's always a second time, okay? So, ready for the big dog. When the big dog goes, big round of applause. Now, I understand that you kind of, it wasn't quite enough, was it? It was like quite good, nearly good, but you won't go away thinking what great chemists Englishmen are. So we actually smuggled in, past the organisers, the biggest one ever. No, seriously, we made the biggest ever barking dog. So this is our last experiment. If you like the show, I'm Professor Hal. If you didn't like it, his name is Dave. Where are you? Don't get it. Where is it? Oh my goodness. No! No way! Yes way! The timing. Sideshow Dave. And for Father Mike. And for Sideshow Hal. And for Iman and Nikita. I'm Professor Hal from the University of Brighton. I get paid to do this. I get paid to travel. So follow science. Okay, thank you very much.